Okay, so let's make a slightly different circuit. Let's have same voltage difference here. Let's place a resistor there, resistance R0. Let's have a similar resistor here. And let's add now resistors in parallel, but let's put 3 of them in parallel. So we allow the current to break up here. Into 3 separate pieces. We'll make the resistors all the same, so we know the current breaks up evenly. So let's find first the equivalent resistance of the circuit. That's going to be, these two are in series, and we need an equivalent resistance here. Let's call the equivalent resistance of this part R. So this becomes 2R0 plus what that R is, and that R is given by 1 over R equals 1 over R0 plus 1 over R0 plus 1 over R0, which is 3 over R0, and therefore R is R0 over 3, just like before it was R0 over 2. So our equivalent resistance is 2R0 plus R0 over 3, which is 7R0 over 3. Okay, let's find the total current, meaning the current going through here and here. So I total, right, we need the total voltage here divided by the equivalent resistance, and that's V0 over this, which is 7R0 over 3, and so that's our total current. And of course, because we have same values of resistance in all of these resistors that are in parallel, we know that each resistor in parallel, so let's say I, the current through each resistor in parallel, IP, must receive a third of this, must be V0 over 7R0. And let's check that by using Ohm's law and conservation of energy. So let's see, so the current IP by Ohm's law, so the current going through each of these is voltage over resistance, and the resistance of each resistor is R0, but what's the voltage across each of these? Well, it must be the same, and it must be V0 minus the voltage across these two. So it's V0 minus twice the voltage across this one, because the voltage across this one and across this one must be the same. In fact, from Ohm's law, we know that the voltage across each of these is just the current, the total current times R0. And so we get the total current is this. We multiply that by R0, we get 3 V0 over 7. So we have 3 V0 over 7 as the voltage across this and this. So over both of them, we have to multiply that by 2. And that gives us 6 V0 over 7. And we have 7 V0 over 7 minus 6 V0 over 7. So we have V0 over 7 R0, as we in fact wanted to show.